The central limit theorem can allow us to calculate probabilities with the help of z-scores. The central limit theorem, which applies to the means or averages of samples taken from a population, states basically three things. Number one is that if the population the samples were taken from has a normal distribution, the sample means together will also have a normal distribution. Or if the population is not normally distributed, but the sample size is greater than or equal to 30, the distribution of the sample means will approximate a normal distribution. Number two is that the distribution of the sample means will have a mean that will be equal to the mean of the population. And number three is that the standard deviation of the sample means is equal to the population standard deviation divided by the square root of n, with n being the sample size. One of the benefits of the theorem is that we can use z-scores to calculate areas of probabilities. And real quick, z-scores convert data to apply it to a standard normal distribution with a mean of 0 and a standard deviation of 1. In which we can then look up the z-score in a z-score standard normal distribution table. And this table will give us the area or probability to the left of a z-score. The formula is z equals x bar minus mu divided by sigma over the square root of n. So in this equation, x bar is a mean value that we're going to be given in a problem. Mu is the mean of the samples, which is the same as the mean of the population, as stated in the central limit theorem. Sigma is the population standard deviation, and n is the sample size. Let's look at a problem, which can help clear up any possible confusion you may have. Let's say that the average tennis serve is 110 miles per hour, with a standard deviation of 5. If a random sample of 40 serves are selected, what's the probability that the mean of this sample is between 109.5 and 112 miles per hour? Since the sample size is greater than or equal to 30, we can draw a normal curve, and we have the mean of 110 here in the middle, and we're looking for the area or probability of between 109.5 and 112 here. So we need to convert both 109.5 and 112 to z-scores. Using our formula, we have z1 equals 109.5 minus 110, the mean, divided by 5, the standard deviation, over the square root of 40, the sample size. And we get negative 0.6325. And doing the calculations for the upper boundary of 112, we get z2 equals 2.53. Next, we need to look these up in a z-score table. For z1 of negative 0.6325, which we can round off to negative 0.63, we get 0.2643. And for z2 of 2.53, we get 0.9943. Both of these tell us the area or probability to the left of the z-score, as you see in these illustrations. So we can subtract the area of z1 from the area of z2 to get the area between. 0.9943 minus 0.2643 equals 0.73. So there's a 73% probability that we obtain a sample mean between 109.5 and 112 miles per hour. Alright my friends, that be the basics on how we can use the central limit theorem along with z-scores to find the probabilities for sample means. Hopefully this video helped you out. I do have more videos right there for you. Till next time, I am out of here.